Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem, that is sort list. Let's read the problem statement. It's a medium type question. We are given with a head of a linked list and we have to return the list after sorting it in ascending order. Let's see how we can approach this. So we will use merge sort for this. And merge sort is based on divide and conquer. Dividing the list with the middle point, middle node. So to find the middle node for the list, we will use a slow fast approach. I have already explained the slow fast approach in my one of the previous video, finding the middle element in the linked list. So you can watch that video to better understand the slow fast approach. So let's start. The head will start from the pointer 5, and after performing the slow fast approach to find the middle element, we'll have slow at pointing at 4 and fast pointing at 3. We will have another new pointer previous that will point just below the slow pointer. So we will divide the list into two halves. The left half will be the list pointing from head to previous, and the right part will be the list pointing from slow to fast. So the left we will pass the head as the starting node, and for the right we will pass the slow as the head node. Now we have head, and for the next iteration we have head and previous pointing to 5, and again finding the middle element, our slow will point to 2 and fast will point to 2. Again we need to divide this list into two halves, that is 5 and 2. So we will divide the left part from head to previous. So head and previous are both pointing to 5, so there will be only one element on the left, and again on the right slow and fast pointing to 2, so there will be only one element 2 on the right. So here again we will do the same thing for 4 and 3 list, that we will have to find the middle element. So as slow and fast is pointing to 3, as slow is pointing to 3, so slow will be our middle element. So we will have to divide the left part from head to previous, and the previous will be just before the slow pointer, that is pointing to 4. So again here there is only one element on the left after dividing, and on the right side again we have only one element, 3. One important point, performing the recursive call, we have to eliminate this link between the previous and the slow, otherwise it will go in the infinite loop. So that's why we will in each recursive call we'll make previous.next equal to null, so that this link is broken. Now as we reach the last node, we see that there is no way to perform left and right recursive call. So this node cannot be broken down into simpler nodes. This is the least possible node we can have. So we have to then backtrack or go up. So because we have reached our base condition, either the node can be equal to null or node.next, if it is equal to null, then we have to return back. So now comes the point of merging that we have to see. So when we will merge these 5 and 2, we have to take care of merging, taking the element smallest element first and the largest element next. So let's see how we can merge. So at this level we have 5, 2 and 4 and 3 as left part of the subtree and the right part of the subtree respectively. So we will merge 5 and 2 and 4 and 3 in ascending order. So let's see how merge works. So in the first list we have 5 and the second list is pointing to 2. So we will make a dummy list node and a tail that will point to dummy, and the tail.next will point to end. Now we will compare 5 and 2. As 2 is smaller than 5, so we will change our tail.next to 2 the smallest element, and we will also, so as soon as we do tail.next to 2, the dummy.next will also get changed to 2. Now we have to break this link from tail to dummy, so we will assign tail to the tail.next. So now tail will point to 2, so that tail can freely go from one node to another without changing the dummy next pointer. Now once we have chosen 2 from the second list, we have to increment the pointer from 2 to the next 2.next, that will be end. So second pointer is pointing to end, so we have only left with first list. So we'll directly change our tail.next from 2 to 5. So this, the tail.next was pointing to 2, now it's pointing to 5. So when we are changing our tail.next from 2 to 5, the 2.next will also get changed from end to 5, and dummy will still pointing to 2. Similarly, we will do here with 4 and 3, as 3 is smaller. We'll again create a dummy and tail list nodes. The dummy, as soon as the tail was pointing to dummy, as soon as 3 was smaller than 4, so we'll assign tail.next to 3, so the dummy.next will also get assigned to 3. We have to break this link from tail to dummy, so we will also assign tail to tail.next, that is tail will point to 3. Now the second pointer was pointing to 3, we have to change it to the 3.next, that will be end pointer, that is null. So the second pointing is pointing to null, and the first list pointer is not empty, so we will take this. So now we will remove our tail.next, we'll point tail.next from 3 to 4. So if you see, this point is changed from tail to 4, and also we'll change our tail from tail to tail.next, tail equal to tail.next, that will be pointing to 4. So as soon as this merging at this level is performed, we will return the dummy.next value, because dummy.next will point to all these values. If dummy.next will point to 2 and 2 will point to 4, so we have a link, that is, we will, when we return dummy.next, we are returning the head of the merged list, that is 2. Here also, when we are returning dummy.next, we are returning the head of the merged list, that is 3. Now from this level we have returned to the upper level. Now at this level we have 2, 5 and 3, 5 returned from the lower level. Now we have to merge these lists in an increasing order. So let's see how we can do it. So in the next iteration, when going backtracking for the upper level, we have list 2 to 5 and 3, 4. So first pointer is pointing to 2, second pointer is pointing to 3. So we'll compare 2 and 3, as 2 is smaller than 3. So again 2 is 3, and we have already created a dummy and tail list node as similar to previous steps. Now we will assign our tail.next to 2, and ultimately dummy.next will get assigned to true. Now the first, as we had taken the number from the first list, we will increment our first.next from 2 to 5. The second pointer will still be pointing to 3. Now we will compare 5 and 3. So as 3 is smaller than 5, we will change our tail.next from 2 to 3. So here the tail.next got changed from 2 to 3, and ultimately the 2.next, which was pointing to 5, the next pointer element in the first list, it will be removed and it will automatically point to the 3, that is the next node for the 2. Because we have changed tail.next to 3, the 2.next will also get changed to 3, and this link will get broken. Now, and once we have taken 3 from the second list, the second pointer will change from 3 to 4. Now we will compare 5 and 4, because from the first list only 5 is remaining, and from the second list it is pointing to 4. As 4 is smaller, we will again change our tail.next from 3 to 4. So we have changed our pointer to 3 to 4, and also 3, that the next pointer in 3 will get changed from 3 to 4. So there is already a link between 3 and 4, so it's there. And now this we'll increment our second pointer, which will point to null, end, and 4 will point to end as well, because there is nothing after 4, so it will be pointing to end. Now we will only 5 is left from the first list, so we'll directly see that the second list is empty. We have one element from the first list, so we will take our pointer tail.next will point to 5. So where we have this, we have changed from tail 4 to 5, and both first and second pointer will increment, change from their respective list to the end pointer, and then we'll return dummy.next, the first node of this merged list, that is 2, from this list, from this step it will be returned, and after this the merge list 2, 3, 4, 5 will be returned outwards. So this is how we do merge, sort, and divide and conquer. So let's see the code part. Simple recursive call to do the sorting, to divide. So this is the method that will divide the list into 2 halves. So to find, in order, we will first have our base case, that is if the head is equal to null or head.next is equal to null, we'll return with head. As we saw that if the head.next is null or if the head is null, we will return the head value. Now we will start with fast, slow, and previous pointers as stated for the slow fast approach to find the middle element, and we will break the pointer, the link between the left subtree and the right subtree, left part and the right part that we divided, so that it's not the recursive recursive call, and it's not an infinite loop. Now the first performing the iteration recursively until unless we reach the base our base case, then we start the merge operation. So let's see the merge operation. As we talked about, that we'll create dummy and tail will point to dummy. We'll first iterate till when we'll iterate from both first and second when they are not equal to null. So we'll keep on taking the elements from both the lists, and if the first dot val is smaller than second dot val, we'll point our tail to the first element from the first list, and we'll update the pointers respectively for the first, and tail will also point to tail.next. Else if the elements in the second list is smaller than the first, then we'll update our tail.next to second, and second will be equal to second.next, and also we'll update our tail equal to tail.next, so that their link, so that this link between tail and dummy is broken, and also every time the tail points to the last element of the list. So as soon as if any of the first or the second list is empty, we'll just see whether which one is empty, and we'll assign the tail.next to the that one which is not empty. So if first is not equal to null, we'll assign tail.next equal to first, else tail.next equal to second, and finally we'll return our dummy.next in each iteration. So hope this hope you like this video. Let's talk about the time complexity. So the time complexity will be n log n. To iterate the tree, to traverse the tree, that is n, order of n, and for each iteration we are finding the mid by dividing the list into half, so that will be log n. So the total complexity will be n log n. Thanks for watching this video, and I hope you like this video. Please share and subscribe to keep me motivated to present more videos like this. Thank you.